So I promised a little explanation of what functional programming was. So let's try to remember the picture we had in mind the whole time about the von Neumann model. So we have some data here, and at each step we're acting on the data with some action. Okay, so a program was a sequence of actions that was performed on the data, and the data would constantly change. Now this was represented in the program. I can take the same picture and I can expand it if you want. At each line you can have in your head the data. So this is supposed to represent the different lines of your program here. So you have the data and different variable names here and there. Okay, different objects also over here. And then you transition, you apply an action, and you end up with a new set of objects, so new data. And then you apply a new one, and so on. Okay? And this is each step of your program is transitioning from one state, what's called a state, so all the data, to another state, another set of data, and so on. And what we would name, it would tend to be that we name some objects here. So we bind them to some names, right? So this is the variables we've been using. And also we tend to name some functions, and the functions were some set of initial data, so the arguments of the function call, some set of final data, the data that is actually returned, and then within the body of the function we were defining essentially the same picture. So we had a series of steps transitioning from one state to another all the way to the final result. And then we were naming this whole thing as a function, and then we were transitioning, maybe going through the usage of one function like this to another part of the program. So this was the general picture so far of imperative programming, right? So this is not functional programming yet, it's more imperative programming with some functions thrown in. Okay, so now we're going to do something slightly different. It will look like a graph again for you, and maybe a very similar graph, but the point is that we'll emphasize different things on this graph. So we'll still have some data, some initial state, and some final state that we want to reach. The point is we will reach that final state by applying a series of actions. That will still stay true. But instead of thinking about what happens here, what is the state over there? Well, surely there is a state, but we won't emphasize that. What we'll emphasize is which function we call afterwards, and which functions we will join the output of the previous ones, and we'll package this whole thing, this whole guy here, into a new function. So the emphasis is not on the intermediate states that are reached, but on how you get there. So on packing up all the functions together, all those arrows, all those actions into bigger actions, and so on, and more actions there, and this is all packaged into bigger and bigger things that you can then compose to get from this initial state to this final state. So it's pretty much the same picture. Of course, it's running on the same computer. It's still running on the von Neumann computer, which has actual data and actions to perform on, but the difference is that when we program, we decide to emphasize a different thing. We don't emphasize the states and the objects with variable names. We emphasize the transitions between states, so those functions. Of course, those functions are also objects, so we still name objects. We'll still use very much the same syntax, but the point is that now we tend to name functions rather than states. Okay, so now we'll see how this translates in practice in Python. And you'll see that it's actually quite simple. It's by introducing three major functions called map, filter, and reduce, and doing pretty much all of it from there.